Thank you for joining nCipher and Micro Focus Voltage today for this webinar, Bring Your Own Encryption in a Hybrid and Multi-Cloud World. My name is Juan Asenjo and I'll be your moderator. Before we get started, let me go over some housekeeping items. The first part of the session will be presentation, followed by questions and answers. You can submit your questions anytime during the presentation using the questions area on your panel. We will compile questions and address them at the end. We are looking for a lively discussion. During the session, you can download a number of resources, including this presentation deck, a joint solution brief, data sheets, a key management for dummies ebook, a case study, and a cloud security data privacy booklet. You can download these from the attachments and links tab on your panel. Our speakers today are Sid Dutta and Temme. Sid is the Senior Data Security Products Executive driving product roadmap and strategies for cloud enablement and integrations of Micro Focus Voltage secure data and secure data as a service. Sid brings a unique perspective to this webinar because he has been in the enterprise side as a customer for many years. With that experience, he is going to share with us the challenges that he has faced and the direction that he has chosen when needing to deploy solutions. Sander is Senior Product Manager for Endshield and Endshield as a Service hardware security modules. In this capacity, he guides the development of cloud computing products at nCipher. He has close to 20 years experience in the IT security industry and also brings a distinct angle to this discussion, having had customer-facing experiences that enable him to set the strategic direction of the product line. As far as the agenda that we have for you today, Sander is going to get us started covering how cryptographic keys and how they typically protected in the cloud and how shifting security requirements are changing the way that customers consume cryptographic services. He will then explain how nCipher Endshield as a service addresses these different requirements with various deployment options. With that groundwork, Sid will then examine what cloud service providers themselves are offering in terms of cryptography and key management services, and focus on how customers can take their encryption and key management from existing on-premise deployments to multi-cloud environments, leveraging the combined capabilities offered by Voltage Secure Data and Endshield Hardware Security as a Service. So without further ado, I'm going to hand it over to Sander to get us started.
Thank you, Juan. I'll advance my slide. I've actually long likened hardware security modules to those glass cases with gloves you put your hands in to work with dangerous materials. You get to use the keys, but never have to actually touch them with your bare hands. Of course, this analogy breaks down very quickly under close scrutiny, but it does show HSMs as a safe place to do cryptography with those protected keys. All around, you see customers move workloads to the cloud. Customers see compelling advantages of scale, agility, and the opportunity to streamline their operations and compliance. Keeping cryptographic keys protected in this new environment comes with a whole new set of challenges, from workloads running on shared infrastructure to highly ephemeral deployments that need to be provisioned with the right keys at the right time. To accommodate our customers deploying in the cloud, nCipher has introduced Endshield as a Service. Endshield as a Service makes available the Endshield platform in the cloud. It provides cloud-hosted applications access to the features that Endshield customers know and love: FIPS 140, validated HSMs, security world key protection, and the code-safe secure runtime. In combination with on-premise Endshield HSMs, Endshield as a Service allows our customers to develop a deliberate, gradual approach to migrating workloads to the cloud. Of course, we would all love for our applications to be fully cloud-enabled, dynamic and elastic, scaling on demand, But for real-life scenarios where we don't have time to rewrite our applications, but we have to take them to the cloud or cloud-like infrastructure, we can now offer a seamless migration option. And this is important because we are seeing that the cloud migration is well underway among our customers. There are compelling advantages to operating in the cloud, and after a decade of testing the waters, the move is on. We at nCipher need to meet you on your way and help you along in this journey. Most importantly, the security controls landscape is changing. Instead of relying on in-house expertise and physical controls to secure our deployments, we are now managing third-party vendors and fourth-party vendors, or vendors' vendors, and assessing their compliance with relevant regulations whenever we have to substantiate our own. Physical controls such as smart cards are inconvenient for cloud deployments and even impossible to enforce in highly automated and auto-scaling situations. Physical controls are giving way to logical controls based on application instance identities that are, or should be, provided by the deployment environment or orchestration tool. Most importantly, since cloud migration is an irreversible trend across many businesses and disciplines, regulations and compliance regimens will adapt. It will go from, you can never do this in the cloud, to, well, this is how you could do it in the cloud in Engine. We don't remember ever not doing it in the cloud. So what should you watch out for? The biggest danger is that in the race to the cloud, organizations are wishing away their security controls. They reassess their use of key protection, reclassify deployment sensitivity and business impact, and in order to meet deadlines and deliverables, may water down the security of their cloud deployments in ways that are hard to find and harder to fix when discovered. Instead of watering down, look for suitable alternatives. For instance, do you need to use manually formed keys, or can transport keys be derived from asymmetric keys established on either end of the connection by a cloud application orchestration tool? Can you use a central key manager to populate a container deployment as it spins up for a workload? Finally, some things that just have to stay on-premise because there is no suitable cloud-based alternative yet. If a key needs to be formed from paper shares, or a root certificate authority must be offline per PKI policy, we simply cannot do that yet in a world where everything is predicated on being online.
All right, thanks, Sander. Hello, everyone. It is Sid. Wow, how I wish, when I was back, on the enterprise side, that we had some of these capabilities, offered and then addressed, and exactly some of the challenges that you talked about, Sander, we had to live with on a pretty much a daily basis. And having done this across two very, very large enterprises in the financial services sector, part of global companies, and one of them having to go through multiple mergers and acquisitions. So we had multiple flavors of cloud usage, a different maturity of crypto key management capabilities, and obviously a lack of an enterprise standard for addressing hybrid as well as multi-cloud strategy. Now, before we kind of go into some of the voltage secure data and the cloud services offering, I mean, there's obviously some of these things need to be understood in terms of moving data to the cloud and what it entails in terms of security risks, and particularly what we are seeing about insecure APIs, issues on the provider side, misconfigured servers, external attacks, accidental errors. So misconfiguration remains the number one cause of data breaches in the cloud. The hackers are going after servers that haven't been set up correctly, allowing them to view sensitive information and extract it with minimal effort. And the situation gets worse when the cloud-based security controls can be tough to figure out and easy to overlook. Assigning access permissions to S3 buckets and their contents are kind of awkward and complex, especially at scale. And there's a funny anecdotal comment from Bob Worrell, a Juniper CIO at that time, said that if you approach cloud migration just as any other IT project, you're dead. You just don't know it yet. And some of the surveys that conducted by IDC, Flexera, we talked about enterprises adopting cloud or migrating to the cloud. It has some very, very staggering numbers. So 93% of enterprises stated that they were using multiple infrastructure clouds for their business operations. And 87% have a hybrid cloud strategy. And particularly in the age of COVID-19, 59% of enterprises expect cloud usage to exceed prior plans. So what are they really consuming in the cloud? And what the data says that the biggest one has been database as a service at 63%, and jointly followed at 56% by data warehouse service and platform as a service. So essentially, when it comes to platform as a service, you don't have the option of choosing the version of operating system, or the CSP manages the infrastructure for you. You don't have access to remote into that virtual machine, and if that operating system needs to be updated, the service provider does that for you on their own schedule. Now, there's another aspect which is getting very popular, another service, which is functions as a service, or serverless compute, which basically is a kind of a misnomer. I mean, of course, when serverless doesn't mean there's no server, but it's using computing power without explicitly allocating a server only for your use. And customers obviously doesn't control or have any control of the infrastructure that the cloud services provider provisions, to run the functions. Now, what we're seeing is traditional ways of doing things about, implementing defense in depth. Those are great, right? And people are relying on some of the inherent controls that the cloud services providers are offering, while migrating data and workloads into the cloud. But it needs just one miss across these various layers of the defense in depth strategy to open the door to any bad actor. And the level of control that enterprises have with these cloud, those layers are getting blurred and intangible for them to effectively manage. So let's take a look at voltage secure data. And this is obviously a very, very busy slide, and I'm not going to really go through each and every portion of it. But the core is at the middle of the picture, where you see the key services and the REST services and the HSM integration. But how we use Endshield HSM for key derivation. It's a stateless architecture on the voltage side that we don't really store any keys. They are derived out of the HSM, and then you have multitude of clients across different platforms. Starting from mainframes to your nonstop open systems, data warehouse services in the cloud or on-prem, and you've got functions as a service, serverless compute, where people are essentially using voltage and integrating with the secure data infrastructure. And then, of course, expose REST APIs, for certain use cases where you do not have the ability to, embed any sort of encryption client. And on the other side, we expanded, that capability, even for SaaS. And what that means is basically that when you're pushing data into the cloud, the SaaS services like Salesforce, Office 365, and many others, the interception technologies are also applying the voltage, secure data protection, on the wire. Or when you're writing data into a database, and there's also a transparent level of interception, at the JDBC, ODBC layer. So one of the things that people often confuse about regarding the difference between an incident and a breach, right? So a security event that compromises the integrity, confidentiality, or availability of an information asset is called an incident. But an incident that results in the confirmed disclosure of data to an unauthorized party, that's a breach. Now, data-centric protection with encryption, tokenization, or any sort of obfuscation at the field level, at an application layer with voltage secure data, can prevent an incident to escalate into a breach. Even though if you can't stop data to get stolen or exfiltrated due to the various factors we talked about, you can certainly make it useless to the perpetrator. Now, of course, while customers are moving data to the cloud and considering some of the native services that each of these cloud services providers offer, let's take a look at what these different services are. So I think I commend the cloud services providers for doing a good job in terms of providing these services. Obviously, these were not developed from the ground up, kind of a bolted on capability. So there are obviously some level of challenges in terms of the maturity and also ubiquity. So we will talk a little bit about those. Now, of course, one of the things that the cloud services providers make it very clear and push this model of shared responsibility, that there's a difference between security in the cloud, versus security of the cloud. And security of the cloud is obviously those things that the cloud services providers, offer and that they are responsible for. The security in the cloud is what the customers are responsible for. And they're the owners of protecting data, the applications, workloads, putting in the right configuration of permissions, access, identity. These are all, part of the customer's responsibility. And this is actually often overlooked from the customer perspective. It somehow has created this perception that, cloud services providers have gotten this covered because they are already offering this. Sometimes, it's natively offered, it's automatically turned on, but it needs to be understood. Now, of course, cloud services providers do offer some of those native server-side encryption in a lot of cases. By default, they are turned on, but they're not really doing much in terms of protecting the data. It's kind of very, very, transparent in nature. There's not much sophistication in terms of those controls and how they are exercised. And basically, whoever has access to and has permissions to the data essentially comes out transparently. So we're not really going to talk, too much about transparent encryption and the issues and challenges and what really they're buying, for the enterprises. But we're going to focus on data-centric, encryption or tokenization capability, which what you see on the screen are enabling the customers to leverage. So we've got the KMS, or the key management services, that cloud services providers offer. And then they are basically a key broker, and they expose APIs for managing keys and secrets. They're not really used for bulk data encryption. However, they're used to protect small data elements or secrets or keys. But essentially, the whole model of KMS is based on the master key and the working key structure. The master key, or sometimes called the customer master key, CMK, can be considered as a KEK, which means a key encryption key that you use to protect your data encryption key. And the data encryption key or the working keys are the ones actually which protect your data. And you can also generate data encryption keys from these CMKs or the master keys. And these master keys never leave the key management service. So those are basically, they are stored there. If you have a data encryption key that needs to be protected, you send that data encryption key to the KMS to get it encrypted by the CMK, and vice versa. If you need an encrypted data encryption key to be decrypted, you go back to the KMS to get it decrypted. And these CMKs either are stored or managed within software, or inside of its compliant HSM managed by the cloud services provider. Cloud HSMs, is a model offered by CSPs or cloud services providers in which keys are stored in a FIPS 140-2 compliant HSM that are hosted by the CSP, but managed by the customer, from their VPCs or VNets, and they're dedicated, to the customers, typically in a single tenant model. And sometimes key management services will also use a cloud HSM if the customer, has one and opts, for a custom key store setting where the CMKs are stored in the cloud HSM instead of being managed outside of it. We're going to talk a little bit about envelope encryption in the following slide, and then we'll look into some of the other capabilities that the cloud services providers are offering, like bring your own key, bring your own KMS, and we'll touch a little bit upon Google's new service, which is called BYOK. So let's move on to the next slide. Envelope encryption. This is the practice of encrypting clear text data with a data key, and then encrypting the data key with another key. And cloud services providers, typically will offer, SDKs at the application level to perform envelope encryption. So what happens is, as you can see from the diagram, you either generate an encryption key locally at the application layer, or you leverage the KMS and the CMK to generate that data encryption key. Now, KMS will provide you with an encrypted version of that key. So you basically have the plain text key that will be used to protect the data, and you have the encrypted key. And you use the plain text key to encrypt the data, and then the encrypted data and the encrypted key are stored together. So that's what the envelope. So just quickly on envelope encryption, as I was talking about, the practice of encrypting clear text data with a data key, and then encrypting the data key with another key, and then storing the encrypted data alongside, the encrypted key together. And typically for any decryption operation, you basically have to get that encrypted key decrypted, out of a KMS or HSM, and then obtain the clear text key in order to decrypt, the encrypted data. So basically, for all these operations, there's a trip, back to the KMS, because that's where the master key resides, for getting that encrypted key decrypted. Now let's move on to the bring your own key. So bring your own key is, as I was talking to myself for a lot of time without realizing lost audio. So it's an acknowledgement, on the cloud services provider side about the growing concerns of creating and storing and generating and hosting and managing keys, on the cloud services providers end, which are essentially used to protect their customers' data. And basically what they have enabled for customers to bring the keys, onto the cloud services provider's KMS. And you can generate that key at your end. Cloud services providers will offer you with a public key, and bound with a certificate, basically for you to wrap the key at your end and then push the wrapped key to the cloud services provider. And optionally, you can actually send a cryptographic hash, for the integrity, or sometimes an import token to ensure that you are pushing the keys for that specific CMK or particular account. And then the cloud services providers will unwrap the key at their end and then store it. Now, keep in mind, the bring your own key essentially applies to the CMK or that key encryption key level. So you're not really pushing the data encryption keys. So what you're doing is you're pushing those CMKs. Now those CMKs can be used to either generate data encryption keys or encrypt or protect the data encryption keys. Even from a key rotation perspective, the rotation capability on the enterprise or the customer side is confined and restricted to that CMK level, and not at the data encryption key level. Bring your own KMS is just another extension of this, which I think from a security standpoint, it's a little bit better, where they have introduced another layer in the key hierarchy. So we already knew about the data encryption keys, that were either generated locally or generated out of the KMS. They are encrypted. And in order to use that data encryption key, you'll have to go and decrypt those data encryption key using the CMK that are stored in the KMS. But in the bring your own KMS level, the CMKs are also encrypted, and they have to be decrypted by another key that resides external to the cloud services providers. And you could have an on-prem environment, own KMS, or managed service KMS. And that CMK has to go and basically get that encrypted CMK to be decrypted so that you get the clear text CMK, which can decrypt the encrypted data encryption keys, and then the encrypted data encryption key or the clear text data encryption key can be used to decrypt data. So it's one layer after the other, and sometimes it feels confusing, but it's not that. It's just adding another key on top of that hierarchy that protects, the lower level keys. So let's move on to the last item in the cloud services provider suite of services in the key and crypto management space. Google DLP. It's a composite service, and obviously by the name, data loss prevention, Google does a lot of the scanning and the classification and the capabilities to inspect the data and understand whether this data is sensitive based on predefined dictionaries or custom dictionaries or rules that the customer can create. So they typically expose three different APIs. One is the inspect. So if you have unknown data coming in to the cloud, let's say IoT, streaming, or social media feeds, and so on and so forth, where you haven't classified the data before, and you don't know what to do with them until you know what sort of data is coming. So you could call that inspect API and get that data classified based on those dictionaries that are pre-built. And once you've identified whether it's a credit card number, a social security number, or a name or address, then you can basically call their de-identify API. Now, as part of the de-identification, Google allows you multiple techniques like redaction, masking, date shifting, and even format preserving encryption. That's a new one that they've added. And the keys for those data de-identification can be either generated by the application and embedded in the API request header in the clear, which is obviously not that good, or it could be wrapped by a master key within Google KMS, or Cloud DLP can generate that key within the system once the API call is made. So these are the list of services that they are providing. So now let's take a look at some of the issues and challenges with them. Of course, first and foremost, these services are tied to the individual cloud services provider, right? So obviously they are not multi-cloud or cloud agnostic. So if you are in AWS or you are in Azure, then these services are restricted within the confines of that particular cloud service that you're using. You can't just port over data and workloads from one cloud to the other and expect to get those keys and the crypto capabilities to just port over. And a lot of cases, if you were to do that, you are looking at a major rekeying exercise, meaning bulk decryption of all data and then re-encryption of the data as you move. So obviously that's not something anyone on the enterprise side would want. So it kind of inhibits enterprises to implement a multi-cloud or cloud agnostic, and even from a hybrid model as well. One of the things that they don't offer too much is the lack of the key management abstraction. So as you've seen, the keys can be generated locally, and then the application developer manages it. Depending on what sort of key diversity they're using, what are they doing with the plain text keys? Are they storing someplace? And whether every single key is protected, while they are not in use. When the data, the key gets decrypted from the KMS, what happens to that plain text key? And so these are some of the things that are very much out in the open, and it's up to the due diligence and the best practices that enterprises will have to put in place to ensure none of these exposure happens. But at the end of the day, these are exposure points. Lack of encryption format choices, another data obfuscation option. To elaborate on that, obviously you don't see anything more than standard AES 256-bit encryption with CBC mode across any of these. Google is probably one exception with their DLP product offering format preserving encryption, but again, it's just restricted to doing data encryption, keeping the format and length. There's not much sophistication in terms of how FPE can be offered. Plus, you don't see any tokenization solution. So it's very, I would say, rudimentary in terms of what choices you have for data protection. Performance and resiliency, I think this is one of the things that people don't really take care of initially because they're more focused on the functional aspects. But it's just like the 8 fallacies of distributed computing, right? I mean, there's The fallacies are that the network is reliable, the latency is zero, bandwidth is infinite, the network is secure, topology doesn't change, there is one administrator, transport cost is zero, and the network is homogeneous. When it comes to a service that has to be called every time a single data element needs to be protected or unprotected, and you are dependent on the underlying network, it poses a tremendous risk. And I can just talk from my experience, having worked in those two major services, one with 115 million cards in force, and think about having to search on encrypted credit card data or decrypting, decryption requiring, information to display the data to a customer phone app or website, or while they're on a call with the customer service rep, or in another case, processing 40 billion credit card transactions while the customers are waiting for transactions to go through an opt-in authorization. And I'm losing connectivity or experience high latency to the KMS to decrypt my keys. I mean, these are some of the things that, it's not going to scale, right? So that's some of the issues I find, particularly in a large-scale deployment where you are leveraging some of those envelope encryption and network-reliant services. Then, of course, you've got some issues with homogeneity and global availability of services. Not every region of the cloud service provider offers the same, crypto or key management services. Sometimes, if you were to implement an encrypt here, decrypt there, then you want to persistently transport encrypted data over to another region in a global landscape, and then you do not have the ability to use that CMK in that other region KMS without having to come all the way down on the other side of the world. Those are some of the challenges that you'll find. All right, so let's quickly move on to our next slide, talking about voltage secure data and Endshield. So why voltage secure data and Endshield, and what are we talking about here to address some of those challenges that we talked about? So first of all, we'll talk about MultiCloud Hybrid. It's a cloud agnostic solution, right? So this enterprise-grade data security solution. A lot of big enterprises, including the ones that I've been part of, we've trusted this solution in order to implement a robust hybrid and multi-cloud, because obviously we were multi-cloud, we were hybrid. It offers a stateless solution. So there's no storage of keys, or there's no PAN token vault mapping or database to maintain. There's no concept of transporting keys when you need to send data encrypted in an encrypted form to another application or another side of the world. There's no requirement to transport your keys. It abstracts the key management and crypto operations from developers or sysadmins. That's one of the things that is very crucial for me, and how I looked at it. That how do I make key management totally abstracted from the developers, so they never get possession of the physical keys. All they know is an identity which is appointed to the key to use that in their application. And all the key management, key derivation, key rotation, key caching is taken care of by the solution itself. It supports local client-based operations for when you need like tens of microsecond level of per field data protection performance. I mean, that's wicked fast. And of course, across a range of platforms, as well as remote operations or REST operations, and a wide range of, possibly the widest range of crypto obfuscation methods. And I can just have an entire session on those individual capabilities. Format preserving encryption. Obviously, we don't want to belabor the point of what it brings to the industry from a value proposition. But outside of that, you've got the partial format preserving encryption. You've got the embedded format preserving encryption. You have obviously protected ciphertext or tokens. You have the stateless tokenization. And then, Voltage is the only one in the industry to offer a solution for safe Unicode FE that prevents any sort of normalization impacts after data has been protected. And also the only one to offer irreversible format preserving hash for data anonymization cases. So that's one of the value proposition. And of course, the system can be deployed in various models, on premises, IaaS, PaaS, and it also supports, the applications who are consuming it, who are on-premises as PaaS or even SaaS. And then, of course, various cloud integrations, as people are moving data to the cloud, consuming these database as a service, data warehouse as a service, ETL service, streaming platforms, Voltage integrates to pretty much across all the major cloud services providers. And plus, of course, from a compliance perspective, FIPS 142-2. So let's quickly browse through the next 3 slides, and we'll open it up for Q&A. So this is just a model where Endshield and Voltage has been deployed for years on-premises data center. And to support enterprise cloud applications, the model was either to have those clients embedded or expose the REST APIs. Obviously, this didn't scale that much when there was a lot of workloads that were moving, and nobody wanted to take a trip back to the data center. So we introduced another model in the next slide, which is basically how you host secure data in the cloud. And then this was again the offering, which was a virtual appliance. You have a AWS AMI or an Azure image, and if you want to host the system in the cloud, you can. You have the option to either use your on-premises HSM or integrate with Endshield as a service. And the last but not the least, we didn't really stop here when it came to cloud. That instead of deploying specific cloud images. So we made it cloud agnostic because obviously it's not just AWS, Azure, and Google, but you've got IBM Cloud, you've got the LE Cloud, you've got VMware Cloud, any cloud for that matter, or even on-premises when you're using, let's say, an OpenShift platform as a service, leveraging Kubernetes and Docker. I've got Rancher, Pivotal Cloud Foundry. So a lot of enterprises have a very robust private cloud where they're leveraging containers for their workloads. So now secure data is broken down into microservices that are containerized and can be orchestrated using Kubernetes and Helm charts. And you can treat it as any other business application and tie that back to your CI/CD and DevOps pipeline and manage infrastructure as code. You get the ability to spin up containers as many as you want in a scale up, scale down. You've got the advantages of those replica sets that if one goes down, you can self-heal and automatically restore your original capacity. And then, of course, everything that containers bring to of never guessing the capacity and implementing a bare minimum capacity and only to be scaling and being elastic. So there's a lot of advantages. So we can definitely have a different session just talking about the secure data new architecture along with Endshield as a service to support our customers moving to the cloud. So with that, I'll hand it over back to Juan.
Yes, thank you very much, Sid. And so now we're just going to cover the takeaway. So Sander, if you want to cover that, and then we'll come back and take the audience questions.
Yeah, thank you, Juan. Thank you, Sid. So I think what we've seen is we've looked at HSMs, we've looked at data protection, and I think this is a very rich tool set that we can use to implement security controls that we need for our organizations to do what we need for data protection and to exercise the controls we need to compliance in cloud environments, in hybrid environments, between on-premise and cloud, and in multi-cloud environments, to take control of how we encrypt the data and how we control that encryption. And so both HSM in Endshield as a service, as well as Voltage secure data, can play an important role in that. And so that is really where the rubber hits the road. We can introduce that high assurance key protection, that strong control on the use of keys, and that localization of where the keys get used and by which applications, and then branch that out into security controls that actually something to the data and that can be applied in all of those different scenarios that Sid just sketched out.
Yep, yeah, absolutely. Yeah, and I think one of the things we talked about, the separation of duties and how to abstract the key management and separate the data and keys from administrative oversight, whether it's a DB admin or developer, because hackers are not out there to break your encryption, and then they're looking for the keys. They're looking for the secrets that gets them access to the keys, and eventually the data. So it's very important for you to ensure that your key management and secrets management never becomes the Achilles heel or the weakest link in the data protection strategy. A lot of experts have told that encryption is easy, key management is hard, and we here in Micro Focus and nCipher are making your job easier to ensure key management is done easier, simplistic, secure. And of course, another takeaway is stop relying on server-side database or file system transparent encryption. We always talk about shift left, when it comes to application security and stuff. This is another model where you shift up, and shift up means shift up the stack where you apply your crypto controls. So essentially meaning apply the protection at the data level and at the application layer, so the data stays protected persistently, regardless of whether it's being pushed to a database or sent to an API, written into a file system, migrated to a cloud, S3 bucket or data warehouse system.
Well, thank you very much, gentlemen, for such an excellent presentation, and apologies to our audience for the technical difficulties we had. Please remember, you can still submit your questions, and now we're going to address some of these that are coming in. So the first question I have here, I think it's for you, Sander. It's what if I have some legacy keys on existing systems using discontinued HSMs? Can I manage those? And you help migrate them to the Endshield as a service environment?
Yeah, absolutely. If you have existing Endshield deployments, then we can migrate the keys over, and we can do so secure. Right? We have mechanisms for that apply all the security controls that come with the security world that we use for key protection that allow you to do a very secure key migration. If you have different brands of HSMs, it kind of depends on what those HSMs offer in terms of making those keys exportable or extractable. So that's often a more complicated proposition that we will have to take a look at from through a professional services lens. See if we can do that, and that is very much done on a case-by-case basis. It really depends on what is in place at the customer, and so much as we'd like to avoid, as Sid pointed out, we would like to avoid having to do key migration by bulk decrypting and re-encrypting data, which is often hard to do because your data goes places, it lives on backup tapes. You need to be able to get those backup tapes back. So you can't just leave the keys behind while you still have a retention requirement for those backups. So it does become complicated, but there are ways to migrate keys and do so securely.
Okay, thank you. So the next question is, what is stateless in the context of voltage key manager and tokenization? Sid, I think that's for you.
Yeah, great question. The stateless aspect, which essentially means that there's two ways to answer. One, when it comes to key management. So, typically there are few models of managing keys. Either you generate the keys randomly, and then you basically store them for applications or clients to use those. And the other ways are you derive the keys. So essentially, from a voltage perspective, the key derivation is the model where we have a derivation function that leverages a master secret that's stored in let's say Endshield HSM, and the key derivation function operates on that master secret and then identity, which I talked about, which is a pointer to the key, to generate the key on the fly. So there's no key store. So if you happen to use 10 million keys, you're basically not storing them any place. So essentially that reduces the whole attack surface. That if someone were to kind of attack the Voltage secure data key services, hoping to find keys, they won't, because Voltage doesn't, store any keys. So that's the stateless aspect, one of the aspects of it. When it comes to tokenization, traditionally, you all know that we had this, database vault, where there's a credit card number mapped with a randomly generated, token, and then basically you have that mapping together. So whenever it came to de-tokenization, you look for that token and then associate that with the PAN that is attached into the table. So that essentially the whole PAN token mapping database, keeps growing, and obviously you have to replicate, sync, and have that eventual consistency. Sometimes there are risks of not only issuing duplicate tokens or issuing the same token for two PANs. And then, of course, the risk aspect of how do you harden that whole infrastructure and make sure that nobody gets into that vault, because that essentially is the key, that mapping, right? If someone hacks into the vault, game is over, right? Because they've got all the credit card numbers and the associated tokens with it. So stateless tokenization on the Voltage side is, again, not leveraging any sort of persistent storage and generating those tokens on the fly. And then this gives a tremendous capability of this protect here, access there model, where you can independently, if you're authorized to use a particular key on one side of the world, let's say in Americas, and you can encrypt the data, and on the other side of the world, you need to decrypt that, you don't necessarily have to transport that key to that other application. I mean, that other application can independently derive the key out of their local instance of Voltage and nCipher, and basically generate that key as long as they are authorized to do that. So that's a model which is tremendously, from a scale perspective, helps, particularly for large global organizations.
Yeah, and I think as much as a stateless situation here, it is you could even see it as a transfer of state, right? You don't keep state at the server end because you don't have that token vault, but instead you hand the token back to the application that asked for it, and thereby you transfer that state. And now the application has it, and if the application has to take it back to a different instance or a different region to get that token de-tokenized and, for instance, get a card number back, then they have all that is needed to do so to take that back to the Voltage service. And that is a very powerful concept. It's, you hear of RESTful services, and that state transfer is really the essence of how that works and how that makes applications very scalable and agile.
That's right.
Well, thank you. And a reminder to our audience to keep the questions coming. You can do that right there on your panel. And the next question is, you mentioned bring your own key for public cloud. Which cloud service providers do you support? Sandra, would you like to take that one?
Yeah, we're actually very agnostic on which cloud providers we can support. So it's basically, since the HSMs are hosted outside of individual cloud providers for Endshield as a service, it is wherever you choose to come from. And so we have customers coming in from AWS, we have customers coming in from Azure, and some even from their own private clouds, because it's all a network connection. So that's very easy to accommodate. So in that sense, we're very flexible as long as we can run the client software, we can accommodate.
Okay, thank you. So speaking of BYOK, the next question, where do you think BYOK or BYOKMS makes sense?
Yeah, that's a great question. So obviously, Voltage and nCipher, we've always talked about bring your own encryption, right, to the cloud. So essentially, don't just push your keys there and thinking that you are doing a great or rather a better job in terms of protecting your data just because now I have pushed my keys there, so everything is great. I talked about some of the issues with where keys can be pushed, but again, when you don't have the full control of who has the keys and how they're being used and where they're being written, essentially it doesn't matter how much data you're protecting. So our model has been to provide that whole stack of bringing your own encryption, not just the keys, but the crypto libraries, the abstraction layer, and of course the keys. And of course, developers or administrators never really have access to the keys because they are interfacing or using a whole solution. And that's what we call bring your own encryption. Now, there would be certain cases where you won't be able to bring your entire encryption stack, particularly like, let's say, the software as a service model, right? Because there's, as we know from the infrastructure as a service and the platform as a service and the software as a service, the layers start to get reduced of how much control you have and what do you really have access to. So when it comes to installing any client or making any application level changes to make a REST call, you lose that, a lot of that, when it comes to software as a service. So there, you can't really bring your own encryption stack. And I think the only thing that is left to you is bring your own encryption key, or bring your own key, because some cloud SaaS providers will offer that. Salesforce.com, I know they have their Shield platform, which basically does the encryption, and they allow you to bring keys to the cloud, and then of course they manage it and host it at their end. In a lot of cases, SaaS providers, to just protect data going to the SaaS, you could implement something like a voltage sentry, which is more of a encryption gateway, at the egress point where data never leaves the enterprise, to the cloud encrypted or in the clear. It gets encrypted on the fly, and then when you view the data, from a browser or whatever application you're using, the data gets transparently decrypted. So those are other solutions you have. But in a lot of other cases, you may not be able to implement that, or there's other workflows happening on the cloud in the SaaS space, where if you can't take your encryption, at least take your keys. So that's where probably it would make a lot of sense.
Well, thank you very much, gentlemen.
In many situations, it is about it's about the control that a cloud provider offers. Right? They are, we're doing this in order to maintain control over the encryption we use and the keys we use them with. So when you're in a bring your own key situation or you bring your own crypto situation, look at what the cloud provider offers in terms of control. Does their capability to use the key timeout? Do they offer regional controls on where that key gets used, which provider regions it gets used in, etc.? That differs between cloud providers, and so with your BYOK strategy, you can implement the controls or enforce the controls that the provider offers. And with the bring your own encryption strategy, you have a higher level of control over what happens to your data and to the encryption that protects it. Sorry, Yuan, back to you.
Well, thank you. I'm just going to say that great presentation and great discussion, and unfortunately we are out of time. So on behalf of nCipher and Micro Focus Voltage, we want to thank you for your participation and trust that you found this presentation useful. If you have any remaining questions or if you would like to contact our speakers, their contact information is displayed here on screen. We ask that you also take a minute to rate the presentation, and remember that a recorded version will be available shortly in the BrightTalk channel, from where you can share it and download it, and download also those additional resources that are there. So with that, thanks again, and have a great rest of your day.
Thank you.